Hello YouTube, welcome to what is hopefully the final video in my series about sorting out a lighting issue that I've got at home using Tasmota firmware intelligent switches. So if you haven't seen the previous videos, or if you want to know what this is all about, then yeah, I'll leave a link in the description or at the end to the first video in the sequence. But yeah, in this video I'm going to be hopefully finishing up. So I've already got one Tasmota firmware switch installed which actually turns on and off the lights. And in the second video I programmed up the second switch to act as a messenger to send a message to the first switch to actually turn the lights on from a different location. So now what I need to do is install the second light switch here. Now this is the downstairs switch for the upstairs light, and there's also a switch upstairs for the upstairs light. So between the two of them, as is common in most houses, you can turn the upstairs light on from both the top and the bottom. They alternate the switching. Now for me to replace this one with a double switch, one of which will continue to do that circuit and the other one which will send a message to the one at the other end of the corridor here in order to turn on these hall lights. I need to get this off, but also I need to figure out what we've got in here in terms of wiring, because the smart switches are basically small computers and they need a live and a neutral in order to power the small microcomputer that does all the work. And most light switches don't have that. They'll have a live coming in and then a switch live going out, but there's not usually a neutral in there. So because this acts as a double switch with the one upstairs, there should be some extra wires in here that I can perhaps repurpose. So let's get the cover off this, see what colour wires we've got, what's in there, and then make a plan as to what we can do with what we've got.
Okay, so this is kind of what I'm expecting to see based on my knowledge of how these alternate switches work. So you'll have a live coming into one of them, and then depending on which position the switch is in, we'll connect it to either, in this case, the red or the blue wire, which will then go through to the other switch, which, depending on which position that's in, will connect to the actual switch live that will go through the bulb and to the neutral. So if the switch on the left is connecting to the red wire and the switch on the right is connecting to the red wire, then the bulb will be on, and if they're both connected to the blue wire, then the bulb will be on, and if either of them's connected opposite to the other, then the bulb will be off. So that's what I'm expecting to see. So let's see if that's what we've got.
Okay, so this is what we've got downstairs. We've got obviously the earth, and then we've got a red, a blue and a yellow wire. This is what we've got on the upstairs socket. So again, we've got the red, blue and the yellow wire and the earth. And we've also got a black and a red. And this is what we've got at the actual pendant. So no sign of the coloured wires, just the brown and the blue are the leads leading to the actual light, and then you've got a whole sequence of blacks and reds, which will be the lighting circuit as it goes around the house. So now I've got the backs off, this is what I've actually found, which is not what I was expecting, obviously. So we seem to have this black and red lead wired in at on the upstairs socket onto the blue and the yellow leads. And I'm not sure what the point of that is, but
Okay, so I need to try and figure out which one of the red lines is the switched live and which is the actual live. So I've got to do some tests and then try and figure out what's going on here. So we need to work out which end has the switched live and which end has the live. So this is the switch at the bottom of the stairs. So I would assume that the live would be the red wire going in at the top, because you've got two wires coming out at the bottom, which you would expect to be where it's switched one way or the other. But the only way to find this out is to test it. So if I can use my multimeter to measure the voltage between each of these lines and the earth, I should be able to figure out which one is permanently live, if any. And if none of them are live, then we can try the one upstairs and work out whether one of those is the permanent live. To be sure I've got this right, I'm going to connect the yellow and the blue together here with a wire, and then I'm going to measure the resistance downstairs between the yellow and the blue, and there should be very little resistance, just the lengths of wire. If it shows up as somehow having much higher resistance than that, it means that there's a break in one of these wires, but it should be correct. So let me try that. Let me multimeter connected up, and it is showing that, yeah, they're basically very little resistance. So there's no break in those wires. So now what I'll do is I will connect one of those to the red wire and then check at the top, and what we should see is there should be what should happen there. Yeah, so the red wire, one end of it will go to the bulb, and the other end of the red wire upstairs would go to the bulb. So they should show a much higher resistance than 3 ohms, which is what this is showing, because it will be going through the bulb. And if that's the case, then that means that I am right in what I'm thinking. Just connect the yellow and the red wires together. Connected the yellow and the red wires to my meter, so now let's put it on, measure the resistance. My meter's a bit broken. It's taken me quite a while, but I finally think I figured out what is going on. So what I think we've got here is the live and the neutral are wired directly to the blue and the yellow lines, and then what happens is the red lines coming off each switch go to either side of the bulb. So if you've got the switches in one orientation, then the live and the neutral will be connected one way round on the bulb, and if you have the switches in the other configuration, then the line and neutral are connected the other way round on the bulb. But because it's AC, it doesn't really matter, so the bulb will come on in either case. But if you've got the switches both so that both lives are connected to the bulb, then obviously no current will flow, and so the bulb won't be on. And equally, if you've got both neutrals connected to the bulb, no current will flow, and so the bulb will be off. So I think this is the situation. And actually, this works out really, really well in my favour, because what it means is we've actually got a live and a neutral going to both sockets already. So I don't actually have to reconfigure any of the wiring at all. I can just connect the blue and the yellow, which will be my live and neutral, to my smart switch, which will power it. And then I just connect the red line out of L1. And the same for the upstairs one, and it should work in exactly the way as it does now, but obviously working with the new sockets. So this is fantastic. I was hoping, or actually I was thinking that I would have to actually sort of change the configuration of some of the wires and wire things up the way they weren't before. But actually this is the best I could have hoped for. So I'll do a test now and see if we can get the two smart switches connected up, and let's see if that actually works. These power wires that bring power into the socket, the live and the neutral, are actually made of aluminium rather than copper. So I have to be quite careful because they're quite easily broken, because aluminium's quite soft compared to copper. So I've wired the switches on, but I'm just going to do a double check before I turn the power back on. So we've got the blue wire as the neutral, the yellow wire as the live, and the red as the switched line to the bulb. Up here we've got the blue line going into the neutral, along with the black, which is the neutral mains feed, the yellow going into the live, along with the red, which is the mains feed, and then the light switch for the bulb going into L1. Although I think actually we probably want it in L2, but for now we'll just test it with L1. So it looks good. I'm going to go and turn on the power and let's see if it works. No explosions. Okay, so we've got blue lights, which means this has got power. That's a good sign. And we've got blue lights on here too. This one is flashing because this one hasn't actually been set up to connect to the Wi-Fi yet. This is a new one, but the one downstairs is the one that you saw me configure in the previous installment. So now, if I click this switch, the lights should come on. And that one has, but that one hasn't. Now that one's still on. Okay, something not right there. The problem with this setup is that it relies on the switches connecting the bulb, either side of the bulb, to either live or neutral. The smart switches, all they do is switch a live. So I can't just literally just wire them in exactly like is shown in this diagram, because they were both just switch live onto either side of the bulb, but there's no neutral, so the bulb would never light up. So what I'll have to do is permanently set one of them to be connected to neutral, one side of the bulb to be connected to neutral, say the one on the downstairs, and then have the upstairs switch switching the live, which will make then the bulb come on, and then I'll use a MQTT message to send a message from the downstairs switch to the upstairs switch telling it to turn on whenever you push the button downstairs. So there'll be no physical switching going on from the downstairs switch. It will only actually be switching the light from the upstairs switch. It'll just do that via a message. So it'll work in effect the same way as the switch to the other end of the corridor will do. So on the downstairs lights now, what I've done is I've connected the red line, which is one side of the bulb, directly to neutral. So there's no actual switching going on from this physical switch anymore. This will just send a message to the one at the top of the stairs, and it's the one at the top of the stairs that will actually switch on the lights. But from our perspective, we won't notice any difference. We'll just push this button and the lights will come on upstairs. You push it again and they'll go off. Okay, well I tried that and the lights still didn't come on, and I realised that there must still be a problem with my understanding of the wiring. And after a great deal of head scratching and a lot more testing, I finally figured out what the wiring situation was, and it is this. So the red, blue and yellow wires all just travel from the upstairs socket to the downstairs socket. And what happens is the red and the black wire that are coming in to the top of the upstairs socket are actually a live and neutral, that and it goes through the bulb. So if you physically just touch the red and black wires that are coming in at the top together, you connect the circuit and the bulb comes on. So then what happens is those two wires are connected to the blue and the yellow wires, and when you switch either of the switches, all you're doing is you're connecting the blue via the red wire to the yellow, so you're completing the circuit, and so the bulb will come on. And obviously if either switch is in the wrong position, the circuit is broken and the bulb will be off, and this is what gives you the double switching mechanism. So this is why I was having problems with the lights coming on and staying on and stuff, because actually when I was powering my unit, I was actually running that power in series with the bulb, and that's why the light was on all the time. So this situation is not ideal, because what I've got now is a problem where I don't have a live and a neutral to both the upstairs and downstairs sockets. So what I'll need to do is to run a new lead from the lighting circuit to provide a live and a neutral to the upstairs socket, and then pass that down to the downstairs socket via the blue and yellow wires to provide power for the downstairs socket. And then the downstairs socket will just have no physical connection to the lighting circuit. It will just send a message to the upstairs socket, which is the one that will actually switch the live to the neutral that goes through the bulb, and that will complete the circuit and light up the light. This isn't deep enough for this, because it's got this big sticky out bit on the back. So if I'm going to fit this flush into the wall, I need to make this deeper to the tune of about a centimetre. So I'm going to try and enlarge or cut out the back of this plastic box and drill out the back of the wall behind it enough that this will fit in there, and then I can hopefully get that in and get it flush with the wall and looking nice. I've managed to hollow that out. I was going to change the whole thing, but this is still rigid, locked in place, so this will be fine. There's enough room now for the thing to fit in, so I've just got to wire it in and screw it in, and that'll be this one done. That's that one fixed. So now I've just got to do the same thing for the one upstairs, and then we should be good to go. So this is the upstairs one, got the same problem as the downstairs one. This is not deep enough, so I've got to basically do the same thing to this, pull out this nail, cut out a square out of the plastic box, and then drill through the breeze block behind to make it a bit deeper. And then I also need to run a live and neutral cable from the lighting circuit to here for the microcontroller in the new switch. And that would be difficult because obviously these wires are all channeled into the wall, but luckily as luck would have it, this socket is on the wall of my airing cupboard, so I can just drill straight through here and then run a cable through the hole up the inside of the airing cupboard, up through the roof of the airing cupboard into the loft, and then from the loft across to the back of the light circuit, and just take a live and neutral feed from the light circuit, and then that will all be hidden. So and that should do everything, and then I can also then feed that live and neutral through these two cables here down to the one downstairs, which will be the live and neutral feed for the one downstairs then as well.
So first thing I need to do is to get that nail out and cut the back of this plastic box and drill out some of the breeze block behind to make space. And then I'll drill a hole straight through into the cupboard to run the lighting cable for my live and neutral. So I've trimmed the back of the plastic box out. Now I've just got to drill out some of this breeze block, which is really easy because it's very soft. Just about probably 1.5 centimeters or so's depth. And then yeah, that should be good for the new faceplate to sit on. And then I just have to drill right through to the other side for the cable. So I'll do that next. That's it. So I've hollowed that out, so there should be enough space now, and I've also drilled the hole for the new cable. So now I just need to run the cable through into the cupboard, drill a hole in the cupboard up through into the loft, and then go up into the loft and patch the new cable into the lighting circuit. So I'll do that next. Yep. It's all wired in the loft to the light circuit. So this is now my live and neutral feed for the little microcontroller, and that will also be splayed down this blue and yellow as a live and neutral, which will carry it down to the one downstairs, and then the black one here is what needs to go live when you turn on the switch. So this will go into the L1 on the back of here. And then the red one will not be required anymore. Okay, so I've just got to wire this on now and screw it all onto the wall, and we should be ready to test.
Okay, so this is what we ended up with in the end. So we have a double switch at the top of the stairs and a double switch at the bottom of the stairs. The double switch at the top of the stairs, one of the switches actually physically switches on the upstairs lights. The other switch just sends an MQTT message, which is relayed by my server to the hallway light to turn on the hallway lights at the bottom of the stairs. The double switch at the bottom of the stairs should have no physical connection to any bulbs at all. It's just going to be sending messages. So one of the switches will send an MQTT message to the hallway light, which will physically turn on the hallway lights. The other switch will send an MQTT message which will be relayed to the upstairs socket, which will physically turn on the upstairs lights. And so between all of them we should be able to switch all the lights on in every which way.
It's all finished. So this is the switch by the front door. So if we come in and it's dark, we can turn on the lights and you can see the hall lights come on, and we can turn them off and they go off. Equally, now if we're at the other end of the hall, so now I can turn on the hall lights from this end, and you see they're on, and I can turn them off, and they've gone off. And I can also turn on the upstairs lights from down here, and you can see the upstairs light is on. And then equally I could then go upstairs and I could switch the upstairs lights off from this end, and see it's gone off. And I can also switch on the downstairs lights from up here. So at the moment they're off, and I'll push the button and they should now be on. There they are. And then I can switch them back off from this switch. There we go. Okay, so it's all working. Finally managed to get it finished. So I think there are probably quicker and easier ways to solve this problem. I've seen these switches called Quinetic, and they basically don't have any wires going into them. You just press the switch and it sends a message to the main unit, which then actually turns the light on. and you can use that for any kind of situation like this. But they don't require a power supply, because the actual kinetic energy from you pressing the switch generates a tiny amount of electricity, which is just enough for it to send the wireless signal to the receiver, which then turns on the light. So it means it's a lot simpler than what I've had to go through in order to get this system working. But the one advantage I have with my system is that I can also control it all via Wi-Fi. So I could, for example, turn the lights on and off when we're not here to make it look like the house was occupied, for example, something like that. But anyway, it's all done, and I'll leave a link to those kinetic switches in the description in case anyone wants to do the same sort of thing but do it that way. It would be a lot simpler, but obviously this more expensive because the switches are not cheap. Yeah, I hope you found that interesting. And there'll be another video coming soon, so please do like, comment, share, subscribe, and I will see you all on the next video. Cheers.